Hello everyone. In this video, let me provide you the solutions to practice week 3. Question 1. From the following equation, let's solve x. So here let's make every exponential function in terms of base 2. So 2x times 2 to the 20th power. Now we know 8 equals 2 cubed. That means 8 to the x power equals 2 cubed x power, which is equivalent to 2 to the power 3x. On the right-hand side, we have 16 equals 2 to the 4th power. So this is equivalent to 2 to the 8th power. And on the left, that's totally equal to 2 to the power x plus 20 plus 3x. So we must have x plus 20 plus 3x equals 8x. From here, we have 20 equals 4x. In other words, x equals 5. So the answer here is 5. Question 2. The label on the package of cream reads 24% total fat. So fat takes 24%. And it also reads 64 fat in dry matter. So let me assume the water has percentage x. So we need to solve this x in this problem. So we have other part. For other part, that corresponds to 72 minus x percent. Now, we need to set up equation to solve x. It's based on the later percentage, 64 fat in dry matter. So that means the total fat is 24% over everything except water, which is 100 minus x percentage. This fraction is equivalent to 64%. And from here, we can solve x. So basically 24 over 100 minus x equals 16 over 25. And now we can solve it because we can divide by 8 on both sides. This is 2, this is 3. Now we have 3 times 25 cross multiplication equals 2 times 100 minus x. In other words, we have 2x equals 200 minus 75, which is 125. So x equals 62.5. So water takes 62.5%. Question 3. For how many pairs of positive integers m and n that are no greater than 20, and the following sum is divisible by 10? So here we require m, n is they are positive integer, larger equal to 1, and no greater than 20, so last equal to 20. And we consider the sum is divisible by 10. So on the other hand, we consider unit digit. That's equivalent to the remainder when it's divided by 10. So remainder mod 10. Now let's consider the power 3 to some power and 7 to some power. They're unit digits. For example, if we consider 3 first power, of course, the remainder is 3. If we consider 3 square, the unit digit, of course, is 9. If 3 cube, the unit digit is actually 7. And 3/4, the unit digit equals 1. And if you keep adding the power, the exponent, it repeats because 3/5, that corresponds to 3, 3/6, that corresponds to 9, and then it repeats. So it's a 4 cycle. And next, we consider the remainder of 7 to some power. So 7 first power, which is 7. 7 square, 49. So the unit digit is 9. 7 cube, 3. 7/4 is 1. So we expect repeating pattern later. So 7/5, it go back to 7, and the 7/6, it go back to 9, and it repeats. So this is still a 4 cycle. Right, in order to have the sum to be divisible by 10, the sum of unit digits is also divisible by 10. So there are following combinations. So we have 3. 3 could be added to 7. 3 add 7, that corresponds to 10, which is divisible by 10. And then 9 can be added to 1 to get a 10. And 7 can add 3 to get 10. And 1 can add 9 to get 10. Right? There are 4 cases, 4 combinations to get a multiple of 10. So let's consider the following cases. So we need to have m, okay, if 3m plus 7n, this corresponds to 3 plus 7. That corresponds to m is has remainder 1 when divided by 4, and n has remainder 1 when divided by 4. And the mn are from 1 to 20. So there are 5, each one have 5 choices. So that corresponds to 5 times 5, 25 combinations. Okay. Similarly, we can discuss other combinations. For example, we can have 3m plus 7n. This corresponds to 9 plus 1. This means m has remainder 2 when divided by 4, and n has remainder 0 when divided by 4. It's multiple of 4. Still, we have 5 choices for each one, and totally we have 5 squared 25, pi squared 25. Also, for the third case, we could have 3m plus 7n equals 7 plus 3. That means m has remainder 3 when divided by 4. And n has remainder 3 when divided by 4. This again, we have 5 choices, and totally 5 times 5 equals 25. And then lastly, we have the combination 1 plus 9. This means m has remainder 0 when divided by 4, and n has remainder 2 when divided by 4. Also, each case, we have 5 choices, and totally, we have 5 squared 25. Now we add all those numbers. That corresponds to 25 times 4. So the answer is 100. So here the answer is 100. Question 4. In triangle QPS, angle QPS equals 59, and PSQ equals 60. And accordingly, we can find this angle PQS equals 61 degree, because the sum of angles in the triangle equals 180. So this is 61 degree. And similarly, in triangle QRS, we know there's 2 angles, and the third angle must be 59 degree. Now let's find the longest line segment. So here we like to mention a property. So basically, we have a longer side, a larger angle corresponds to a longer side. For example, here in this triangle, let me show the idea. It's just 60 degree. Suppose this is 59 degree. Now both triangles have the same corresponding angles. They are similar. So here we have 61 degree. For example, we have, it is S, this is a Q, this is P. Now we must have SP larger than PQ Suppose, okay, let me show this property. SP larger than PQ. We can basically draw a equilateral isosceles triangle. I can split this. I can and take a 60-degree angle here and 60-degree angle here. If this is X, I must have SP equals SX plus XP, but XP equals PQ. So it's of course larger than PQ. Similarly, we can argue other comparison. So SP larger than PQ and larger than QS. Now in the second triangle, we have similar relation. S, Q, R. So we have S, R larger than QS and larger than QR. Right? Now let's compare this line segment. In both triangle, we have a common side, that is QS. QS. In the first triangle, the largest one must be SP. That's the candidate. In the second one, the largest one is SR. Now let's show PS is larger than SR because these two triangles are similar. And we have that, okay, triangle PSQ similar to triangle SRQ. Now we have common ratio SP over SR. This corresponds to PQ over SQ. But PQ and the SQ are both two sides of the first triangle. And the PQ corresponds to 6 degrees and the SQ corresponds to 59 degrees. So this is larger than 1. In other words, SP is larger than SR. So the longest side should be SP. That's overall longest line segment. So it is PS or SP. Question 5. A 10-digit number is divisible by 72. What's the greatest possible value of the sum of the number of digits? So let's consider the divisibility by 72. Notice that 72 corresponds to 8 times 9. And let me denote this number as n. It has 10 digits. Okay, now this number is divisible by 72. That's equivalent to this number is divisible by both 8 and 9. Okay, let's consider divisibility for 8 and 9. If it's divisible by 8, that means the last 3 digits is divisible by 8. Last 3 digit makes the 3-digit number is divisible by 8. And the second, n is divisible by 9. That means the sum of digits is divisible by 9. Okay, let me denote that n's digital sum is divisible by 9. Now we need to maximize the digital sum. Of course, it's not. We cannot just make every term to be 9. That because last 3 digits cannot be divisible by 8. However, we need to maximize the digital sum. Notice that 1000 is divisible by 8. So basically subtract 8. That corresponds to 992. Now 992, that's the largest 3-digit number divisible by 8. Largest 3-digit number. And that also provides the largest possible sum in the digits. Okay, in order to satisfy the second requirement, the sum of digits is divisible by 9. And of course, we can not make all this to be 9. Of course, that gives the largest possible sum, but this is not divisible by 9 because the sum should be divisible by 9. So to make this possible, we need to change one digit to be 7 because 7 plus 2, that corresponds to 9. And this gives the largest digital sum, and it's divisible by 72. So the answer corresponds to there are 7 9s and plus 7 plus 2. Basically, we have a 9 times 9, which is 81. The answer here is 81. Question 6. 6 people, A, B, C, D, E, F, attend a party and they shake hands with each other. Not necessarily every pair of 2 people, but each pair of people shake hands at most once. Let me denote A, B, C, D, E, F by these 6 points. Now, if 2 persons shake hands, let's connect them by a line segment. Notice that A shake hands with 5. Okay, A shake hands 5 times. That means A shake hands with everyone. So I connect AB and AC, AD, AE, and AF. So A is done. And also notice that E shake hands only once. We know E already shake hands with A, so E is already done. E cannot shake hands with anyone else. So E shake hands only with A. And next, we consider B. So B shake hands 4 times because there are at most 5 people to shake hands with B. And we know that E only shake hands with A, so B and E cannot shake hands. In other words, B only shake hands with A, F, C, D. But just except E. So that's the scenario for B. And next we consider D. D just shake hands twice. In this picture, we already know D shake hands with A and B, so D is already done. And next we consider C. C shake hands 3 times. We already know C shake hands with A and B. We need one more handshake. The only possibility is with F. So C shake hands with F. Now finally we consider F. We notice that F shake hands with 3 people. So the answer here is 3. Question 7. Kitty has 2 tests, science and mathematics. So the probability passing science is 3/4. In other words, the probability of a fair science should be 1/4. And also, the probability of passing mathematics depends on the result on science. If he passed mathematics, if he passed the science, the probability of passing mathematics is 4/5. Otherwise, the probability is 1/3. In this question, we look for the probability of passing exactly 1 test. So let's discuss 2 cases, either pass science or mathematics. So the first case, he passed science and failed mathematics. That means the probability of failing mathematics should be 1 minus 4/5. Next case, he does not pass science, but he passes mathematics. In this case, the probability of passing mathematics 1/3. So we just consider 2 cases. The first one is 3/4 times 1/5. This corresponds to 3/20. And next case, 1/4 times 1/3 is 1/12. So we add these 2 numbers, that's the answer. The first one is 9/60, and second one is 5/60. The sum equals 14/60. It's simplified into 7/30. That's m/n. Now we have m plus n basically equals 37. The answer is 37. Question 8. A ball starts rolling from the center of 3x4 room in direction 45 degree and to the walls. It rolls in the straight line except when it's bounced off a wall, and it does that at an angle 45 degree, reflected, right? When it hits the wall for the 6th time, which of the following is closest to the travel distance of the wall? So let's calculate the total distance when it hits the wall the 6th time. Okay, for convenience, let me draw grids, 3x4 grids. Let me do 3 rows and 4 columns. The 3x4. Now the ball starts from the center. Center is here, and it rolls in the 45 degree direction. So let me draw the path. Okay, it goes to 45 degrees. So it meet this midpoint and this midpoint, and this midpoint hit the wall the first time. So this is a line, and then it bounced off in the 45 degree direction. This one, and this is also midpoint. Okay, and reflected. It goes to here, midpoint, 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 midpoint here. So it goes down here. And then reflect, okay, it's bounced off and go to 45 degree direction. Okay, and next it's bounced off. Midpoint, midpoint. So now we have, this is the fifth time it hit the wall, and we consider next time. So in the midpoint, 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 midpoint. Okay, this is the 6th time. Now let's calculate the total distance. So basically, we see that each small line segment, like here, is each small line segment corresponds to 1/2 √2. And when we count, there are totally 20 such line segments. So this total distance is 10 times √2. Now √2 is about 1.4 and 1, something like that. So it's almost 14. It's very close to 14. The answer here should be 14. Question 9. For standard dice, the sum of the numbers on opposite faces is 7. Here we have 2 identical standard dice. What's the number on the face marked by this question sign? Okay, let's decide the distribution of numbers on each dice, but they are identical, so they have the same distribution. Let's first consider the left dice. Okay, on this die, we know 3 faces, and basically we determine all 6 faces because the sum on opposite faces equals 7. On the top, we have 2. Let me just use numbers for convenience. This is 2. On the front, this is 1. On the left, this is 3. Accordingly, we know what is on other 3 faces. For example, on the bottom, that corresponds to 5 because 2 plus 5 equals 7. On the right, that corresponds to 4. 4 plus 3, 7. On the back, that corresponds to 6. Okay, so this determines the distribution. Let me show these faces. Okay, now we consider the second die, but the distribution is the same. Here we only know 2 faces. The top equals 6 and the front one equals 4. And we need to check the number on the right faces. So imagine that we rotate the first die to match the second die. And now we have the top to be 6. That corresponds to this 6 goes to top. Okay, top. And the front one is 4. Is 4. So 4 becomes front one. If this is the case, we know the right one corresponds to the original bottom one, which is 5. So that corresponds to 5. So if 6 is the top, if the 4 is the front, and then now the 5 must be the right, the number on the right face. So the answer here is just 5. Question 10. How many different pairs of positive whole numbers have greatest common factor 4 and a lowest common multiple 4,620? In other words, we'll consider how many pairs of A, B, like two numbers, such that their GCD equals 4 and the least common multiple or lowest common multiple equals 4,620. Now the key is to do prime factorization for 4,620. This equals 4, okay, basically 2 squared times 3 times 5 times 7 times 11. That's factorization. Okay, because they have common common divisor equals 4. Basically, we can take A, both of them are divisible by 4, right? So A equals 4x and B equals 4y. In other words, we have the GCD of xy equals 1. They are relatively prime. And next, we can see the least common multiple, xy. We can divide 4, so it gets to 3, 5, 7, and 11. Right, let's see how many pairs of xy are there. So they are co-prime, and then the product equals 3, 5, 7, 11. So xy do not have a common divisor. Larger than 1. And now their least common multiple is this product. So each prime number goes to just one number. So if, for example, 3 can only go to x or go to y, but just one, okay? And the 5 has two choices, go to x or go to y. And 7 go to x or go to y. 11 just go to x or go to y. So each prime number has two choices, which place it goes to, right? So there are 2 times 2 times 2 times 2. There are 16 cases. 16 cases. However, here we just consider pair of xy. The order does not matter, or it's not important. So the answer is 16 divided by 2, which is 8. So that means we have 8 pairs of xy. So the order is not important. So answer here equals 8. Question 11. 3 people, Austin, Ben, and Calvin, run around a oval track. Then they start together. Austin, Ben run clockwise. So suppose they start from here, A and the B run clockwise, and the C run counterclockwise. Now we know their speeds. Austin is 400 meter per minute, and the Ben is 200 meter per minute. C is 150. Now after certain minutes, Austin meet Calvin. First time, Calvin met Austin on his way, and 4 minutes later, Calvin met Ben because Ben is slower. If we draw pictures, maybe somewhere here, Austin runs here, and Calvin runs here, and the Ben is somewhere later. So Ben is here, and after 4 minutes, C meet B. So what's the length of the over track in meters? Here, let's see. After we suppose after t minutes, C meet A. C meet A, and the total distance, the total length of the track, let's call it D. Because Austin's speed is 400 times t, that's the distance run by Austin, and Kelvin, the speed is 150. 150 times t, that's the distance for Kelvin. The sum of distance is the overall distance, which is equals d. Or we just have 400 plus 150 times t equals d. Now, on the other hand, consider Kelvin and the band. It takes them t plus 4 minutes when they meet. So for Kelvin, speed is 400, so times t plus 4. And the band is 200. Sorry. So here, Kelvin has speed 150, t plus 4. And the band has speed 200, t plus 4. This is another way to express total distance d. So equivalent to this is 350 t plus 4 equals d. Now compare the previous one, which is 550 t equals d. We can solve both t and d. First, we notice that we can make 550 t equals 350 times t plus 4. From here, we know that 200 t equals 1400, so t equals 7. So after 7 minutes, Kelvin meets Austin. And then we can use the equation to express d. Let's say, let me use the first one, 550 times t. So it's 3,850. That's the total distance of the check. So that's the answer here. Question 12. How many triples of positive integers x, y, z satisfy the following equation? Here the order is not important. Okay, because the order is not important, we can basically order these numbers. Let's assume, say x less equal to y, less equal to z, and then we see how many triplets there. Note that we have 5 over 6 equals 1 over x plus 1 over y plus 1 over z. Because x is smaller than y, smaller than z, so this is smaller than 1 over x plus 1 over x plus 1 over x, which is 3 over x. From here, we can solve that x is less equal to, 5 over 6 less equal to 3 over x. We can solve x less equal to 3 times 6, 18 divided by 5. Because x is integer, so x must be less equal to 3. Now we also know that x is large equals 2, because if x equals 1, the equation cannot hold because the sum is 5 over 6. 5 over 6 is less than 1, so x cannot be 1. From here, we see that x either equals 2 or 3. So let's discuss these two cases. First case, if x equals 2, that means 1 over 2 plus 1 over y plus 1 over z equals 5 over 6. Subtracting 1 over 2, so 1 over y plus 1 over z equals 1 over 3. Here we only have two variables. It looks simpler. First, notice that y must be large equal to 4 because the total sum is 1 over 3. So y must be large equal to 4. And next, let's see the upper bound of y. 1 over 3 equals 1 over y plus 1 over z, less equal to 1 over y plus 1 over y, which is 2 over y. That means y is less equal to 6. Now, y is large equal to 4 and less equal to 6. There are three cases. Y equals 4, 5, or 6. And then we can double check if we plug in y and you get a z to be integer. So the first case, if y equal to 4, we can get z equals 1 over 12. So we got a solution x, y, z to be 2, 4, and 12. And the second case, if y equals 5, if y equal to 5, there's no solution. Z cannot be integer. Z not integer, not whole number. So this doesn't work. And the third case, if y equals 6, if you plug in, and you will see that z also equal to 6. So 1 over 6 plus 1 over 6, that's 1 over 3. So 2, 6, 6 is also one solution. So this is our cases for x equals 2. Next, we consider x equals 3. X equals 3, we have 1 over 3 plus 1 over y plus 1 over z equals 5 over 6. Subtracting 1 over 3, 1 over y plus 1 over z equals 1/2. Now, we must have y larger equal to 3 because the sum here is 1 over 2. And next, we consider the upper bound by similar argument, 1 over 2, last equal to 1 over y plus 1 over y, which is 2 over y. That means y is last equal to 4. So y can be 3 or 4. Now we can discuss these two cases. If y equals 3, we can plug in and we can get z or z equals 6. 1 over 3 plus 1 over 6 equals 1 over 2. So the solution for xyz is basically 3, 3, 6. Okay. And next, y equal to 4. Accordingly, we have z also equal to 4. So the solution for xyz is 3, 4, and 4. So totally, we have 4 cases. 2, 4, 12, 2, 6, 6, 3, 3, 6, 3, 4, 4. The answer here is 4. Question 13. A circle of radius 90 and a circle radius 40 are tangent to each other and tangent to the two lines in the following picture. What's the distance xy? X is tangency here for larger circle. Y is the intersection of these two tangent lines. Now let's, for such kind of question, a common strategy is to connect the centers for these two circles. We connect the centers. Let me call this center to be A and B. Now I'm also draw altitude from B to AX. Let me call this to be H. And in this way, we know if we extend AB, it goes to actually the intersection Y. Now here, let's first consider triangle AHB. We know that AB corresponds to the radius of the sum of these two radius. So it's 90 plus 40, 130. That corresponds to the hypotenuse of this right triangle. And for AH, that corresponds to the difference of these two radii. So 90 minus 40 corresponds to 50. That's AH. Because AHB is a right triangle, HB corresponds to 130 square minus 50 square square root, that corresponds to 120. Okay. Actually, this is equivalent to 5, 12, 13. This Pythagorean triple. So this is 120. And next, okay, this is a HB. HB is equivalent to X, let me call this P, XP is 120. In order to find XY, we'll also need a PY, okay, PY. Now we use similar triangle. Okay, AHB, AHB is similar to triangle BPY. Because first, both of them are right triangle. And second, we know that this sides are parallel. Angle, let me write angle AHB equals angle BPY. Both are 90 degrees. And also we have angle, because BP is parallel to AX, we must have angle HAB equals angle PBY, okay? Because BP parallel to AX, they have the same angle with the line AY. So that means we have these two triangles similar. This implies triangle similar. Now we can use common ratio. So PY over BP is equivalent to BH over AH. The ratio is 12 over 5. Now we got PY equals 12 over 5 times 40. That corresponds to 96. All right, the answer is basically 120 plus 96 because XY equals xp plus py equals 120 plus 96. That is 216. The answer here is 216. Question 14. Randomly choose two numbers between 0 and 1. What's the probability these two numbers and their arithmetic mean can be side lengths of a triangle? So let me denote these two numbers to be x and y from 0 and 1. Actually, x, y cannot be 0, but let's just write this way. And the mean is x plus y over 2. Okay, in order for this three number to be side lengths of triangle, we must have any sum of two numbers is larger than the third number. So for example, I have x plus y is larger than x plus y over 2. This is of course true, except that x, y both 0, but in most cases that's true. And second case, x plus y, x plus the average is larger than y. Third case is y plus x plus y over 2 is larger than x. So those are requirements for these three numbers to be three side lengths of triangle. Now let's characterize this mathematically. So first, both x, y are freely selected from 0 to 1. That corresponds to x and y are both possible from 0 to 1, any number. So we draw a coordinate system, draw a unit circle, a unit square, 0, 1, 0, 1 here. So any point in this unit square could be xy. Okay, that corresponds to a sample space, all possible xy. And next, we consider these three requirements. The first one is like x plus y is positive. So we just need at least one number to be positive, which is except the case xy both 0. Right. And next requirement corresponds to, okay, let me multiply by 2. So 2x plus 1x 3x plus y larger than 2y, or basically 3x larger than y. So that means y is less than 3x. So let me draw the line, y equals 3x. So the valid points are the points below this red line, okay? And then third case we have for the other way. Basically, we can switch x, y. So that corresponds to 3y is larger than x. So equivalently, y larger than x over 3. Y larger than x over 3, that corresponds to the line with slope 1/3. Let me draw this green line. And the valid points are above this green line. So finally, the valid points are points below between these two lines, red, green. This part corresponds to valid cases. Now let's find the area. So E is basically the total area. The total area is 1 minus the unshaded part. There are two parts. Each part has 1/2 times 1 times 1/3. That's the area for each part. So we'll multiply by 2, subtract that. So this corresponds to 2 over 3. The area is 2 over 3. The probability is 2 over 3 over the total area is 1. So the probability is 2 over 3. That means the answer here is 2 over 3. Question 15. There are 11 red balls, 12 green balls, and 17 blue balls. In each operation, we change 2 balls of different colors into another color, the third color. For example, we can change 1 red ball and 1 green ball into 2 green balls. What's the largest possible red balls can we get by a certain number of operations? So here we want to maximize the number of red balls at the end. So that means we need to maximize the number of green and blue balls, that color, to be red. So each time we need to have a pair of green and blue balls. So in order to maximize this number, we need to minimize the difference of G and B. To maximize, we need to minimize the difference between G and B. For example, if G equals B, we can actually color all of them into red. Each time we get a pair, we can change all green and blue into red color. So that's idea. So let's see, is that possible? Is it possible to have all green and the red ball to be red? Green and blue ball to be red? Let's see. Basically, we consider the difference of G and B. So there are two cases to matters this difference. So the first case is that we can have red ball and the blue ball color to green. So maybe we have some red ball and some blue ball color to green. And the other case is we have some red ball and the green ball color to blue. Now suppose I have 8 operations. In each operation, one red ball and one blue ball changes to green ball. So after that, we have the following numbers. For red ball, we have 11 minus A. For green ball, I have a 12 plus 2A. For blue balls, I have 7 minus A. And next, I may have some operations like I change red and green into blue. Suppose I have B operations of such kind. After that, I have 11 minus A minus B red balls and 12 plus 2A minus B green balls and 17 minus A plus 2B blue balls. Okay, actually we only have this two kind of operation matters the difference, because if both green and blue balls change to red ball, the difference of green and blue doesn't change, right? So let's see. So we have this kind of number for green and blue. Let's minimize this difference. So if we consider minimum number, we take the difference. The difference is going to be 3A minus 3B. So 3A minus B minus 5. Well, this difference cannot be 0 because 5 is not a multiple of 3. It can never be 0. So the maximum number of red ball cannot be the sum 40. It cannot be 40. So the maximum possible is 39. So here, let's minimize this number. So this is larger equal to 1, right? And there are several cases to make this to be 1. For example, I can take A to be 2 and B to be 0. In this case, I have the following operation. So I change red and blue into green. I do this twice. After that, I have 9 red balls and 16 green balls and 15 blue balls. And next, we change this green and blue balls into red balls. This can be done 15 times because we have 15 blue balls. After that, I have 39 red ball and 1 green ball and no blue ball. So the largest number for red ball equals 39 here. 39 is the answer. Question 16. If both 10m plus 11 and 5m plus 27 are multiples of a positive integer larger than 1, what's the remainder when k is divisible by 7? So let's denote, okay, let's notice that 10m plus 11 is basically twice of 5m plus 27 minus 43. Okay, we notice that both of these two terms are divisible by k. That means we have 43 divisible by k. So 43 equals 2 times minus 10m plus 11. So k divides 5m plus 27. K divides 10m plus 11. That implies K divides 43. Because K here is larger than 1, so we must have K equals 43. Now, K divided by 7, it equals 6 times 7 plus 1. The remainder equals 1 here, so the answer is 1. Question 17. In this diagram, square PQRS have side lengths 42. And it's divided into 4 non-overlapping rectangles if they have the same parameter. What's the area of the shaded region? So let's mark this 1, 2, 3, 4. We have 4 rectangles. They have the same parameter. Let's consider for rectangle 1. The length is 42. That's clear. And let me denote the width to be x. We like to solve x. Now consider rectangle 2, the length corresponds to 42 minus x. Okay, and suppose the width is y. We must have 42 minus x plus y equals 42 plus x. Because if each term multiplied by 2, that's the parameter, right? They are equal. The first part is the parameter for a second rectangle. The second part is parameter for a first rectangle. From here, we see that y equals 2x. Y equals 2x here. And accordingly, the length of a third rectangle should be 42 minus 2x. Now, accordingly, let's see the width for the third rectangle to be z. So the parameter for the third rectangle is 42 minus 2x plus z equals twice 42 plus x. So here, we have z to be 3x. Okay. So finally, we consider the rectangle 4. Basically, 4 is congruent to 3 because they have the same length, so they must have the same width. So that means this is 3x, so here is also 3x. Now we know that the width for the first rectangle is x, so totally we got a side length to be 7x. So 3x plus 3x plus x equals 7x, that equals 42, which means x equals 6. Now we are ready to solve the area for the third rectangle. For the third rectangle, we have 42 minus 2x times 3x. That's the area. X equals 6, so this corresponds to 30 times 18. That's 540. The answer here is 540. Question 18. Roll 2 regular dice and obtain values A for die 1 and value B for die 2. What's the probability that the following equation has more than 2 solutions? Now let's check what's the requirement to have more than 2 solutions. First, notice that both A and B are integers from 1 to 6. Now let's try to solve the equation. Because B is positive, we can take square root. So A is x squared minus A. This corresponds to positive or negative square root of B, and this makes sense. And that means x squared equals A plus or minus root B. So there are basically 2 cases. X squared either equals A plus root B, or x squared equals A minus root B. So we need more than 2 solutions. That means we need at least 3 solutions. From the first part, we always have 2 solutions because A plus root B is always positive. So x1 or x2 equals plus or minus root A plus root B. This always always exists. Now let's consider the second case. In order to have more than 2 solutions, the second equation has at least 1 solution. So that means the requirement is A minus root B must be non-negative, larger equal to 0, or A squared is larger equal to B. That's the requirement to have more than 2 solutions. Okay, let's check the value of A and B. So A could be from 1, 2, 3, 4, 5, or 6. So for each case, let's check the possible B. For first one, A equals B, so A squared larger than or equal to B, so B can only be 1. And for the second case, B is less equal to A squared, so less equal to 4. So B can be 1, 2, 3, 4, 4 cases. Now for A from 3 to 6, actually, we can have any B. So B could be from 1, 2, 3, 4, 5, 6. Here B can be 1, 2, 3, 4, 5, 6, any. B can be 1, 2, 3, 4, 5, 6. Now those are all possible A and B. We calculate they are totally 29 cases. And for the combination of A and B, they are totally 6 squared, that is 36 cases. That means the probability is 29 over 36. So here the answer is 29 over 36. Question 20. The figure shows 5 rows, each containing 5 bricks. In how many ways can Maria choose 5 bricks, one in each row? And so any 2 bricks chosen in adjacent rows are adjacent. So basically we need to find a path from the first row to the 5th row, and the consecutive bricks are adjacent. So here, let me do the following. For each brick, let me mark a number. The number determines how many ways Mario could arrive at this brick. So let me put here. Suppose for certain brick, I mark a number K. That means there are K different ways to arrive at this brick. Okay. Now let's start from the first row. For the first row, each break we can just have one way to arrive because that's a starting break. For the first break, I have only one way to get there. Second break, I can only one way to get there. 1, 1, 1. For each break to arrive this break, there's only one way. Now let's move to the second row. For the second row, the number is a sum of 2 adjacent numbers above this row. For example, for this first break here, I have 2 ways to arrive this break because you could from here or from there. So they are basically two ways to here. Similarly, we do the other breaks. So 1, 1, here's 2, 1, 1, here's 2, 1, 1, here's 2. For the last break, I can only have one possible pass. That's from the last break from the previous row. Okay, this idea applies to the next row. So here we consider the third row. To arrive at the beginning break, there's only one way. So accordingly, I have two different ways. And for the second, we have 4, 2 plus 2. There are 4 different paths to arrive at this break. Similarly, here is 4. Here's 4. And here we have 3, okay? 3. Now let's move to the third, to the fourth row. Same idea applies. So this is gonna be 6, 8, 8, 7, 3. And now the last one we have, this is 6, this is 14, 16, 15, 10. So finally, we just need to add all the numbers on the last row. 6 plus 14 plus 16 plus 15 plus 10. This equals 61. So there are totally 61 different paths to go through these 5 bricks. The answer is 61. Question 19. This is a logic question. On the island of knights and the knaves, there live 2 types of people: knights who tells the truth, and the knaves who always lie. Okay, let me draw a table to represent these two people. So here, the traveler, okay, called I. Okay, the traveler asks two persons, the taller one and the shorter one. Let me denote this is taller one, and this is shorter one. So on for the taller one, there are two cases. It could be knights. This person could be knight. That means he or she tells choose, or is knave. That means what he or she said was lie. Also, for the shorter one, still we have two cases. So it could be knights, or that means choose, or knave. That means what it says is a lie. Now let's consider two questions. The traveler asked two questions. The first question is if they were both knights. If they were both knights. Now let's consider the answer. Okay. Also, I just marked this way. The upper part is the answer from the tall man. The lower one is answer from shorter man. So let's see the answers for each case. If both of them are knights, okay. If both of them are knights, basically I'm looking at this square. If both of them are knights, that means to the first question, are both of you knights? That means they will tell the truth. Both people will tell the truth. So the answer will be yes and a yes for both. Now suppose we consider the taller one is a knave and the shorter one is a knight. That means taller one tells the truth, tells the lie, and shorter one tells the truth. So for first question, are you okay? For first question, are you both a knight? Because this is not true. Okay, this is not true. In fact, but because the taller one is a knave, he tells lie. So his answer should be yes. That's a lie. Okay, yes. And now the second question, is the taller one a knight? So because the shorter one is a knave, it's knight, and the answer is true. So the answer here is no. Okay, the fact is that is no. So the knight tells truth. There's no. Now third case, if the taller one is knight and then the shorter one is a knave. For the first question, the taller one is knight. He or she tells the truth. That is no, because the shorter one is knave. Now for the second question, is the taller one knight? The true fact is yes, but because the shorter one is named, he tells lie, so he answers no. Lastly, for the last case, both are named, both tells lie. For the first question, and because none of them is a knight, so the answer should be no, but because they tell lie, so he answers yes. And for the second question, the answer should be no, but because it's a liar, so the answer the traveler got was yes. So that's the answer here. Now let's check the fact in this problem. The traveler, after the first question, the traveler could not figure out who they are. That means it cannot be the third case, because the third case, if you know the first answer is no, you will immediately determine the taller one is knight and shorter one is knave, right? So we must, the cases must be 1, 2, or 4. Okay, 1, 2, or 4. So 1, 2, or 4. It cannot be a third case. All right, and then after the second answer was obtained, the traveler could tell what type of they are. That means the only possible case is the second one, because first one and fourth one, they have the same identical responses, so it cannot be determined. So the only possibility is second case. The taller one is a knave, and the shorter one is a knight, and that's the answer here.